Okay, now we're ready to start HDL coding. So we'll begin with the circuit from Chapter 2 of the Make FPGA book. If you recall, we had a simple counter circuit. We called it our blink system, and that counter drove a couple of LEDs. We took a couple of the signals off the counter, and we use those to drive a red and green LED at different frequencies. And we had a clock input, and we also had a reset push button in that design. We're going to simplify that a little bit, and you can download the code for this from the GitHub repository from my website. If you go to the using code examples section of the book, you can see here's the repository, and that'll be a place where you can get the code. Here's the repository here. You can see the Blink LED system file, the Verilog file, and the Blink system UCF file. This is the file that defines the pin constraints. So we'll need both of those files to build that system. So now we can go over to the Xilinx ISE tool, and we have here the HDL code, and I'm going to create another project here. I'm going to copy this project over to another project. We'll call it, because I'm going to edit this code, we'll call it DuoPWMPinMapping1, and we'll hit OK. Now I'm going to go ahead and open up that project. So we'll go to PWM test 1, and we'll open up that project, and we should have all our HDL there. So here's the HDL from the GitHub repository. We're going to make a few simple edits of this file just to start with. We're going to use this file to test out our pin mapping. Remember, we're going to take the UCF file that is that we used in the Chapter 2 of the book for the Opal Kelly FPGA board, and we're going to have to remap those signals to the Pampilio Duo board. So first we'll make some edits. We're going to simplify this circuit a little bit. We'll keep the clock, but we'll remove the reset. So we can just a couple of forward slashes. We'll comment out the line. We only will have one output, so we'll keep the output high, and we'll do the same here. We'll remove reset. Also back here, you need to take this comma off because it's the last string in the text. So we'll take that comma off, or else you'll get a compile error. All right, so we'll do the same here. We'll remove the reset and that and the high, and now we'll just take out this logic here, this if statement, so we can just comment these lines out. And we'll just leave the begin statement. There's just our counter, our high output, our clock input, and then our output we'll use on clock output 21. Okay, so next we need to do is we need to check our signals, our mapping. Now, in order to do that, we have to go over to the Pampilio hardware guide for the Pampilio Duo on their website, and here's the URL for that. It's a great web page. They have a lot of good information here. There's the Pampilio Duo top side, back side, and they give you a schematic and also the pinout. There's a lot of other information on this page that's very useful. Great documentation from the guys at Gadget Factory. So we're going to use this schematic to find out where our clock input pin is on our FPGA. So when we look at the schematic, we notice that we have the oscillator in is on pin 94. So we need to remember that that's where our clock input is coming into, on pin 94 of the FPGA. The other thing we need to know is we said we were using pin 7 of the Pampilio Duo Arduino header pin. So we need to see how that maps to the FPGA, and you notice the legend here says that the dark gray are physical FPGA pins, and we see that pin 7 of the Arduino is mapped to pin 124 of the FPGA. Now we're using a different package than the Opal Kelly board. We're still using the LX9, but we're using the 144 pin package in the Pampilio Duo. That's the TQG 144 pin package LX9. You can see the P designators here. This is from the Xilinx website. This is the pinout guide for the different packages. So now we have all the information we need. So now we'll just go back to our Xilinx tool, and we'll open this file up. Here's our UCF file that we downloaded from the repository, and we can see we have clock in, high, out low, and reset. We said we don't need these two signals, so we'll get rid of those by just commenting them out. In the UCF file, you have to use the pound to comment those out. So shift 3. So now you see they turn green, they're commented out. Now our clock we said was on P94, and we said our pin 7, our output pin, is going to be on P124. So we have our pin mappings now. One more thing we have to do is we have to change the package. So we'll go to our project, design properties, and you make sure, this is very important, you're going to have to make sure that you're using the right package when you're doing a build, when you're going to create a bit file. So as you can see here, the Opal Kelly was the 256 pin package. We have on the Pampilio Duo, we have the TQ G144, and the speed grade is not that important. We can leave it at 2, and so that's all set. Okay, so now we're ready to do a build. So we just simply do a plus implement. We changed a couple of files, so we want to save those before we get started, and we'll let that run. As that's running, we can go over to getting Design Lab open. So we'll close these down, these windows down, and we'll open the Pampilio Design Lab. And this is the tool that Gadget Factory provides for you to do all sorts of really cool SoC development and system on chip. And it's a great design tool. We're going to be just using a little piece of this right now in this experiment. So we're just going to open the Pampilio loader. Okay, so we're just going to use this this tool here. Now, most FPGA designers have their own loader or bit file uploading software or application. They write for their own boards. So you always have to find out what the board vendor provides for a tool to do the bit file loading of the FPGA. Everyone does it a little differently, so everyone typically gives you their own application to run to do the tool. So this is pretty straightforward. You can write the design right to the flash, and then every time you power cycle the board, you don't have to re-download it, or you can download it right to the FPGA. Now let's go take a back look here. Okay, so that's done here. We have no errors, so that's good. Now we'll double click on generate the program file. So while that's generating, we'll go in and make sure our board is set up okay, ready for the download. We'll plug our board into the USB. Now remember from the book, if in chapter 6, we talked about how to set up the Pampilio Duo for loading FPGAs, and we go to a walkthrough of how to do that. But this picture here is a picture's worth 1,000 words. So basically there's a jumper on the on the Duo board that you have to make sure the block is down in the bottom FPGA position and you're plugging into the USB mini connector. So I'm going to go over to the bench and we'll take a look at that, and we'll plug in the USB cable to our board. So okay, so let's go over here. All right, so from that drawing there, we can take a look at that. Here's the USB cable. We'll just put that over to this, hold on to that for a second. So here's that strap here, the jumper strap, and we're going to make sure that it's connected down on, when we're just programming the FPGA, you're going to make sure the jumper strap is in the bottom position when the board is being held this way, and the mini USB connector we'll be using to program the FPGA. So we'll take our mini USB cable that's connected to our PC, and we'll just plug that in, and we have our circuit all set up. Remember, here's our pin 7, jumping over to our circuit current limiting resistor, and we should be all set to upload that file, and we have the power coming from the board, the power and ground. Okay, so we should be all set, ready to program our bit file, to upload our bit file. So let's go back over to our Xilinx tool, and that's, we got a, looks like we're all set. We have our file, bit file generated. Back to our Pampilio Duo, and now we'll just go to select, and we'll go to that file. It's on IC, let's see, drive, and we'll go to make FPGA, experiment 1, and we said we were in DuoPWM test 1, and there's our bit file. So we want our .bit file, we'll select that, and we're all set, ready to go. Our board is plugged in, so we just hit run. And you can see now that the LED is flashing. So we have our Pampilio Duo now mapped. We're ready to build. We can build HDL files, and in our next segment we're going to start working on developing a PWM circuit to drive our dimming circuit for our LED.